Just now it is visible my screen.
Yes, sir.
Okay. So,
Your voice is slightly breaking, sir.
hello. Now it is clear.
Yes, sir.
Okay. So basically, this is our first question. Our system uses a 800 milliampere hour battery with the rated voltage of 3.6 and maximum voltage is 4.2. We are using the BQ24040. Okay. So he is asking the fast charging current of a given circuit. So how we calculate the fast charging current? Okay, so if you go with the video part, okay, if you go with the video part, so you can see that fast charging current is I out, that is K I set upon R I set. Okay. K I set upon R I set. Now, if we see the data sheet BQ24040, so if you see the data sheet 24045, okay, this is the data sheet. If you see the formula here also, the formula is I out output fast charging. Okay, output fast charging, that is equal to the case I set upon R I set. Okay, now if we are talking about 24045 is when the I out is 52,000. Okay, when I out is 52,000, it is a 510, 560, 585. If it is a 25 to 50 milliampere, is a 480, 557, and 596. And if it is a 10 to 25 milliampere, it is 350, 555, and 60. Okay, so these are the values. So, so if I put it as a K I set value, so the K I set is, now I am taking the 560 initially, okay? Because if you see the typical values, it is around 560, 557, 555. So I just taken 560 upon what is R I set. The question, it is a 1K, 1000. Okay, so it is around a 0.56. Ampere. What is a 0.56 ampere or 560 degrees? Okay. Now, if you are using this 557, okay, so the formula is 557 upon 1000. So it is a 0.557 ampere or 57 milliampere. And third case, if it is a 555 upon 1000, so it is a 555 milliampere. So every case, you can see the value of the I out is greater than I out is greater than 50 million. Okay, because here in the data set, if you see the I out value will be lies in three particularly band. One is the 10 to 25, 25 to 50, and then 50 to 1000. Okay, so what we are using? We are using a 560 milliampere. We are using this 560 because every cases the current range lies. Current will be in this
Okay. Okay, sir.
range. Okay, so what is the fast charging current? It is a 560 milliampere. Okay, so the answer is 560. Now, approximate time taken to charge the battery. So, if fast charging current is 560 and total battery rating is 800 milliampere hour. Question 2 is time. So, total battery capacity of I. So, it is 800 divided by 560. Okay, so you can calculate this one is time is in hour because the battery capacity is milliampere hour. So the milliampere. So the this value will be in hour. Okay, they are asking the minute, so you can convert it to the minute. Okay, now the current come down from the charger to signal that charging complete is in milliampere. Okay. So the formula for this one is percent I term is equal to R term upon K. Okay, R term upon K because it is called the termination. So this is the R term is 5 kilo. R term is 5 kilo. And K term that will be given in the application. Termination, so K term. Okay. Now if from this one you can check that this the formula is also given. Okay. So percent termination you can calculate from this one. So item upon K term. K term is what? Now check. If the pre-term R pre-term is from 2 to 10K, the value of K term is 200. And if pre-term R resistance of pre-term is 1 to 2K, the value is 190. Okay. So in our question, the value of R pre-term is 5K. Okay, so we are considering the K term is 200. So this one is 25. Okay, so this is the termination percentage. Okay, now how much current is total capacity is what? 800 million. Correct. This fast charging current is 560 million. that case.
Excuse me, sir.
Yeah.
Sir, do we have to remember like all these values if it comes in the end term, or would it be provided in the question itself?
In the provided in the question.
Okay, sir. Thank you.
Either the data sheet will be given, okay,
Yeah. Okay, sir.
because there are lots of single battery chargers are available, ICs are available, charging ICs. Okay, so we consider that any particular question if we are giving in the examination, we will give you the data sheet.
Okay, sir. Thank you so much.
Now, first one item we calculate 25%. Now, what is the 25% of the fast charging current? 560 is 560 into 25. So it is a 140 million. Okay, so from the 560 it will become at 140 million. Now they are asking the percent termination current in the schematic showdown in question number 1. So percent we have already calculated the percent termination is 25%. The percent termination is 25%. So percent termination is 20.
Fourth question, sir.
Okay, so B2 51021, this one. If we see the data sheet, we can identify that what is the maximum. So this is the data sheet. So question the maximum output voltage V out that can support by video. So maximum output voltage is this is about the input. So adjustable output voltage 4.5 to 8. Okay, that is the adjustable between 4.5 to 8. Now what is the maximum? It is a 8. Okay. In a given figure below, the maximum output current when a 10 ohm load resistance is connected. Okay, so the what is the output is 8 volts. Okay, the from the current load if you connect a 10 ohm, so what is the current from the 8 volt it will be go to the 10 ohm. So it is a 0.8.
So the answer is showing something else.
So the maximum output current 5.0, okay, 5.01. Okay, so this is the second data sheet 5.013C. It provides me the maximum current. So regulated output voltage is provided between the 5 to 5.01. Okay, if you see in this data sheet. So what is the regulated output voltage that will be provided either 5 or 5.0? Okay, so if this is the voltage provided at the output, so what is the current? So simply if we say that this is the one particular voltage source that will be provided either the 5 volt or 5.01. Okay, and that will be connected with one resistor of level. Okay, so what is the current? 5 divided by 10 or 5.01 divided by 10, so it is a 0.5 to 0.501 amp from 500 to 501. Okay,
Okay, sir. The fourth question we didn't do.
fourth question. Fourth question you have already calculated. Huh? What is the P charge factor from this one? 25%.
Oh, okay, sir.
Okay. Now if you see with the particularly this this charge factor is 100. Okay, pre-charge factor is 100. Okay, because
Yes, sir.
impedance is what? This is your preterm impedance, that is a 5K. Okay, so your pre-charge factor is 100 from this data sheet. Okay,
Okay, sir. Okay, sir.
so if you are talking about the question 4, so you have to calculate the K pre-charge. That is equal to the you have to calculate the K pre-charge, and the value of K pre-charge is 100%. So if you see in the formula, R preterm is equal to K preterm into the percentage of preterm charge. So for this one, we can calculate the K pre-charge is equal to the R recharge into the percent recharge. Okay. Now R pre-charge is what? 5,000. Okay, and percentage of pre-charge that is given in the question. 25%. Recharge current is given at 25%. So we are using the value of 100. Recharge factor to given static. The percentage of recharge current is 20. What is the recharge current? Okay, it is a R recharge divided by. Yes, it is R recharge divided by percentage of R recharge divided by this. So what is the R recharge? R recharge is 5,000 divided by percentage of recharge current is 25. That is it. From percent. Okay.
Okay, sir.
We are not solving this as a percentage. Okay, we are not removing this percentage because your unit, if you see in the question, your unit is in percent, ohm percent. Okay, if you see in the question, it is a ohm per percent. Okay, so don't remove this percentage, not remove or simplify this percentage from into the normal.
Okay, sir.
Okay. Any other doubts? Question number 1, question number 3, question number 5. Question number 5 is similar.
Sir, graded question number 6 to 8. Wait a minute. Yes. Yes. What 6
happened?
to 8. Some hints, sir.
Some hint is that first of all the reference voltage is connected to, so you identify that this is their reference voltage. What is the terminal of this one? Okay, we generally remember and know that operation amplifier will be working in an inverting mode. Okay, that means feedback will be negative, so this one will be negative. Okay, so if this one will be negative, what is the terminal voltage of this one? What is the basic terminal of this one? And if this is an inverting terminal, it is a non-inverting. If it is a non-inverting terminal, it is a inverting.
Will that MOSFET affect something, sir?
Yeah, it is showing the inverting element. No?
Oh, okay, sir.
It is mentioned it is an inverting element. Okay, if the output impedance of the closed loop amplifier is 0.1, then the battery charging voltage will charge them. Now, if output impedance load, we know that it is a 400 milliampere. Impedance we know. Can we identify that what is the voltage drop at the output? Okay, total voltage we know. Okay, total voltage we know. Now, from this one, if the output voltage is using by this particularly current and this particularly, sorry, this particular resistance and this particularly current, we can identify what is the output voltage. Now if we subtract this particular voltage with the from the main voltage, we can calculate the what is the battery voltage at the end of the charge. Okay, now in the question number 8 it is saying that if the load current from the 400 reduces the 150 milliampere and the output impedance is 0.2. Okay, then what is the output voltage? Okay, so you can calculate With the help of these two parameters, what is the output voltage? Okay, now if we remove this output voltage from the main voltage, okay, main voltage is what? We are using the 4.2, no? So 4.2 volts. Okay, so from 4.2, if you subtract this output voltage, you can find out what is the battery final battery voltage at the end of the charge. Okay. Now question number 9, if we say that output impedance of amplifier is twice the output impedance of the question number 8. So we improve the output impedance. Here it is a 0.2, now it is a 0.4. Okay. Then you find out what is the end voltage. Okay. These are from question number 6 to question number 9.
Okay.
Windows 7 9. Now any doubts?
No, sir.
If you need any, if you have any other doubt, you can ask. Yes, any other doubts? No doubt? Yes, no doubt. Shall we stop here?
Yes, sir.
Thank you all.
Thank you, sir.
Thank you, sir.